So we're in Unit 4, Thermodynamics. So we're talking about, well, just break that word down. It is literally thermo meaning heat and dynamics meaning movement. So it is the movement of heat. So we're going to be looking at this in a couple of different ways. And first one is how to write out an enthalpy of formation. So in the notes, we should know how to do that. That will influence your first two reactions. You're going to have to write out a proper enthalpy of formation reaction for both ammonia and HCl. And we're doing, 3 and 4 is just the enthalpy change going from a gas to a solution. And we're doing steps 5 and 6. 5 and 6 are going to be what is the change when we actually react these things together. So we're going to do step 5 right now. I've already taken out some 50 mils of 1.5 molar ammonium hydroxide, and over here I've got 1 mole per liter HCl. So I'm just going to take their initial temperatures and find out what they are. We're going to add them in and just note the temperature change. Now this data, you don't use any of it. All right, you've got your own data. It's going to be online. So you've got individualized, so you're the only person with that set of data. All right, so you're going to be only using your data. All right, so let's get started here with the 1.0 M HCl. We're just going to take its temperature first. So we put this in here, and it's a little bit warmer, 24 degrees. So of course you would have to take your initial temperature, and whenever you take the temperature of your base, now make sure you wipe this off. You don't want the reaction happening on the tip of the probe right here. So I can pour that in, and if there is these have been sitting together, they should be the same temperature, but if they're not, you know what? Take the average of them. That's okay. All right. So let's say they're 1 degree off, or 0.1 degree off, or 0.2 degrees off. Just take the average, because that's your initial temperature. Because remember, we're looking for an enthalpy change. We're looking for a change. All right. So now we're going to take note the molarity. So same volume. It's going to be our 50 mils here. We can take the initial temperature over here, and it was a little bit warmer here. I held up my hand, and my hand's a little bit warm, so temperature was up. Oh, you see, it was a little bit lower. So in this case here, you would take the average of those two as an initial temperature, and I would wipe that off. So now, what we're going to do, now this is going to mix very well, but I do want to note the temperature change as I don't have to stir this at all. And this just helps to insulate it just a little bit, because warm air is going to rise, so any air that gets heated is going to rise through. We're just trying to keep all the heat in there. So we have the digital thermometer ready, and we're going to note the enthalpy change right now. So we're going to pour that in. And just wait for a second, and notice that the temperature is already up. It's gone up to 29.7. You don't need to record that. You've got your own data, all right? So you notice that the temperature started around 23, 24-ish, and it went up to 29.7 or whatever. Okay, that's step 5. Now that's an enthalpy change, and you're going to have to change that into a molar enthalpy change for 1 mole. All right, so just note the difference there. And we're going to get rid of this. That's a little bit warmer. Next, step 6, we're going to do the ammonium chloride. This is just water, so this is our 50 mils of water. And here is our electronic balance. So if it's zeroed and you've got just something to take its mass there, you want to tear the balance. and it calls for about 4 grams. All right, so I've got just over 4 grams of ammonium chloride here. So I'm just gonna put that on the balance, and you see we've got 4.35 grams, which is a little bit high. That's okay. All right, ask for about 4. Again, step 6, use your data. Don't use 4.35, use your data. All right, you have individualized data. And we're gonna pour this water in here and take its initial temperature. Right, make sure this is wiped off. It should be okay. So we want to take, again, the enthalpy change. So we can take its initial temperature. This water is a bit cooler. So this is about 19 degrees. All right, so that's about 19 degrees right now. So we're going to add in, and we're going to have to stir this as well because this is a solid, so we'll have to stir this as well. So we're at 19 degrees. We've got this going here, and we'll get our stir rod in there. And we're going to take the temperature, like that's going to take us furthest away from what, the 19.4 or 5 or something like that. All right, so here we go. We're going to add this in, and I'm going to stir as well. All right, and now we're down to 18.0. Yeah, so this is definitely going down. So I'm going to stir this down to 17, down to 16. So notice that this temperature is decreasing with the solid ammonium chloride. And we're going to get the lowest possible temperature, all right? Again, you're not using this, you're using your data, all right? You've got your own data that you're going to be using. That's unlike anyone else. So we're down inside 14 degrees, we're at 13.6, 13.5, and at some point when this stops dissolving, yeah, that's going to be it. I think we're almost there, we're at 13.4. Quite soluble, ammonium chloride. It's a very soluble chemical. And I think we're at the end there, so 13.3. So, just quick word about calorimetry. Remember, we're trying to create an isolated system here, which means no heat gets in, no heat gets out. This is its own universe. We take water at a certain state, and we want to know the enthalpy change. So, look at the state before and after. Before, we were at 19 or so degrees. And then shazam, something happens, we're down to 13.4. That water went through an enthalpy change, all right? So that's what we're measuring here. And we're gonna have to, of course, change that for equation 6 into a molar enthalpy change. And that's why the mass was so important, right? So that mass was, we wanna be very precise with that mass. Okay, so now, you got to complete equations 1, 2, 3, 4, 5, and 6. You're now going to do a Hess's law problem, and you're going to tell me what is the enthalpy change, or enthalpy of formation for 1 mole of ammonium chloride. Right? You have enough information now, and you've also got some analysis questions as well. Okay.